Hello, welcome to OVP webinar. We have a slight delay, but don't worry, we had some small technical issues. Now we can actually go on with the webinar itself. So security is today's topic. Security relates to all types of workloads, and that includes also containers, especially Kubernetes or OpenShift environments that we are going to talk about with. Today, I'm going to talk about it with Jarosław Stakuń from Red Hat. Jarek, if you could introduce yourself.
Yes, of course. Hi, my name is Jarosław. You can also call me Jarek. I work as a principal solution architect at Red Hat. I'm working mostly with the products and technologies related to the containerization, and of course the OpenShift product family is the core of my interest at Red Hat.
And my name is Marcin Kubacki. I'm Chief Software Architect at Storware. So my background is mostly virtualization and infrastructure in general. So I have a wide experience in all different types of technologies, both these related to infrastructure as well as software development. So let's start with some basic questions. So can you tell us what kind of security issues actually are experienced usually in Kubernetes environments?
Yeah, so I wanted to start with the slide that with the chart that I collected from one of our surveys that we delivered, and here you can see that in fact there is a lot of different security incidents that our customers has experienced in last year. And what is very interesting is that they are very much diverse. So as you can see, the top three are related to the very much different stages of the application lifecycle. So the most common is the misconfiguration, which is most related to deployment of the application. Then we have a application runtime incidents, and pretty much the same value of the vulnerabilities that are detected during the building or compiling the application binaries.
Okay, so how we could approach these different stages if we think about the complete application lifecycle?
Yeah, and having a complete vision and solution that could completely cover the application lifecycle is key here, because you can see that during the application lifecycle, you will have to deploy different security controls, starting from the build phase, where you can see we need to take care about securing our CICD pipelines, detecting vulnerabilities in the images and in the binaries of our application. Then when we go to the deployment, first of all, we need to be sure that we deploy our application into the secure Kubernetes environment, and securing the Kubernetes environments spans really from the operating system level up to the networking and storage and all the application configurations that are needed to deploy the application. And finally, we cannot forget about the runtime of our application, because as you have seen, many vulnerabilities are detected when the application is running, so they have nothing to do with the with what we deployed in the images or what we have deployed, what is the configuration of the application, but this is specifically related to the binaries and the application that are or processes that are running inside our containers. So the key here is really to have a complete solution that will address and will cover all those the whole life cycle of the application.
So if I understood correctly, technically it's not about the OpenShift itself that to provide these all of the security along all of these stages, but probably Red Hat has some other product in its mind, right, to cover these.
Yeah, so exactly, the OpenShift platform itself is, we can say it is a DevOps platform, so it is responsible for quite often for creating the containerized applications or for building the images. It is also the runtime environment, as it includes the Kubernetes, so it is a runtime environment for the application. And we paid a lot of, and we pay constantly a lot of attention to secure the OpenShift runtime itself, so to give you out-of-the-box secure operating system, Kubernetes, and the tooling that we provide in OpenShift on top of Kubernetes. But of course, the OpenShift is not like dedicated security or vulnerability or threat detection solution. And for that, we have introduced a new component called Advanced Cluster Security for Kubernetes, which allows you to extend the security capabilities provided in OpenShift into, let's say, a new level, and to implement really a full DevSecOps approach where your DevOps processes are extended with the security controls that I mentioned on the previous slide.
Okay, so let's talk about this Red Hat Advanced Cluster Security in detail.
Yeah, so ACS for Kubernetes, in short, it has been built on the purpose of the framework that I talk about. So we make sure to address the whole life cycle of the application, which includes the build stage, the deployment stage, and the runtime stage. So the ACS is a complete Kubernetes-native security platform that runs on top of OpenShift, can monitor and manage the security of many different Kubernetes environments, not only the OpenShift, but also public cloud Kubernetes as a service environments, and has been built using a very advanced policy engine that I will show you later on, as well as with a set of APIs that allows you to integrate it easily with the existing CI/CD and DevOps tools that you might have deployed in your organization.
Okay, so last question before the demo, actually, if you could tell us more about the use cases. So when actually I would like to use advanced cluster security?
Yeah, so there are number, actually 6 major use cases for and the capabilities of the ACS. Yeah, so the first one is the vulnerability management, which is pretty much related to the build phase of the application lifecycle. So this is where we want to analyze the application binaries, the images. So we scan the images in order to detect some vulnerabilities that could be present in the container images. Then we have also the configuration management module, which is responsible for the deployment phase. So with this module, you can analyze the Kubernetes manifest to detect some misconfigurations or some possible vulnerabilities that could be exploited at the runtime. Then we have some tools that allows you to automate the process of analyzing and detecting the different incidents at any stage of the application lifecycle. So we have a risk profiler that will show you some more in the more prioritized way what vulnerabilities were detected, which are the most important, how to which vulnerabilities you should pay the most attention to. And also it has a solution that allows you to detect and automate some responses to the incidents that could be detected in your environment. And the last 2 use cases, so network segmentation, very important part. So with ACS, you can also monitor the network communication in your Kubernetes clusters so that you can automate the implementation of network segmentation based on the Kubernetes network policies, so that you can isolate different applications or different workloads from each other. And also there is a compliance module that allows you to automate the procedures for getting some regulatory compliance with different industry regulations like PSI DSS or CIS Kubernetes, for example.
Okay, so now let's do the demo.
Exactly, yeah. So let's start the demo. So I will switch to the OpenShift console. Here we have a so you can see here a dashboard of the ACS. So it is deployed on top of the Kubernetes. In fact, on top of the OpenShift cluster here. So what you can see here on the main dashboard, first of all, you can see that there is quite a lot violations detected in the cluster. So those violations are based on the policy engine that is part of the solution, and those policies are used to analyze the managed clusters, and these are the results here. On the other hand side, you can see also that there are some compliance reports created. So there was a scan executed that has verified the compliance of the cluster with different standards. Okay, so let's go back to the violations here. So let's focus on the critical, as these are typically the ones that you will want to solve or mitigate in the beginning. So here you can see some violations critical with severity critical that were detected in the cluster. You can see that they are also categorized in different lifecycle stages of the application. So the first one is related to the runtime. The other ones are related to the deployment. And here you can see what they are really about. So what they are detecting. So let's maybe open the first one, the execution of AP tables in privileged containers. So quite risky situation that could be the proof of some attack or the attempt to preparation to some attack. So you can see here the details about this specific violation, when it has happened, what exactly has happened. So you can see here that there was a AP tables executable executed by the privileged user, so with the ID 0, so with the root permissions. So we can also check which Kubernetes deployment was the source of this violation. So we see the cluster, the namespace, and the deployment name here, so that we can quickly identify what's the source. And we have also here, we can also have a look here quickly on the policy that this violation is related to. So here you can see the structure of the policy. I will show you it later on in more details, but here just quickly you can see that we have nice description, the rationale, what could be the remediation for to mitigate, to avoid this violation. Also, you can see here that you can specify to which namespaces or to which deployments this specific policy should be executed, or which should be excluded. And here you have a definition. So I will show you later on how to build these policies based on the metadata that is collected by the policy engine. But you can see here the structure is pretty straightforward. So we see there is a privileged container, the process that is executed, it's called AP tables, and the process UID is 0. So this is what this policy is detecting. Okay, so now let's move on quickly to the other view. So the risk profiler shows us the prioritized set of the most risky deployments, Kubernetes deployments that are running in our cluster. So we can pick the first one on the top and see what was detected, what different security issues were detected in the deployment. So first of all, you see quite long list of different policies that were violated. Then you can see that there were some suspicious processes executed. So the this is the related to the running processes inside the container in this or in the containers in the pods that were created using this specific deployment. Then you can see that those there are some there is a lot of vulnerabilities detected in the images that are used in this deployment, container images. So just a summary of, you can see here over 500 CVEs detected. So very large number. What are the different security configurations that are inside the deployment? So you can see that we have here the additional capability added. So the SecOp capability. We can see that the container, one of the containers in deployment is running in the privilege mode. So we see that there is some elevation of privileges here in this specific container. Then we see some services that are exposed. Also, the SSH port could be here a very interesting to understand why is it exposed. Some binaries, some components deployed inside of the container, which might be useful for attackers to conduct different attacks here. So we can see some tools like, for example, Netcat, which also sounds quite suspicious. Yeah, what components are here in the image? How old or how fresh are our images? So we can see this image is over 500, almost 550 days, so very old one. And also the airbag configuration here. So also you can see that, for example, there is a service account that is executing this image, and this service account has a cluster admin privileges here. So also very large elevation of the privileges. Then, of course, we can analyze the deployment itself, and what is very interesting here, we can also analyze the running processes in the pods that are deployed in this deployment. So you can see here some processes are automatically flagged as a kind of risky processes. So here we can see for each process what were the parameters, what kind of commands were executed. So, for example, here quite interesting to see that there is a netcat that is connecting to some, trying to establish the connection with some interesting host name. We can also look on those processes in the timeline. So we can somehow correlate and analyze. Here we can see what were recently executed. We see some kernel with some very strange parameters here was executed. So quite suspicious behavior as well. Yeah, moving forward, we can also have a look on this deployment in the network graph. So if we click, we can move to the network graph, and it will show us what were the network connections executed. And again, automatically some network connections will be flagged as a suspicious, so as anomalous flows, and some other will be considered as a kind of baseline standard communication network communication activities. So being here, and maybe let's just narrow the view to the namespace where this specific deployment is located. We can see here in more details what are the connections between different deployments, different pods in the process in this namespace. And what is very nice here is that you can also generate quickly here the network policies. So based on the baseline communication that is recorded by the by ICS, the generator will automatically create for us set of network policies so that we can easily implement them just to isolate the communication in this namespace just to the pods that are considered as a safe. This can be, of course, extended by the administrator to open some other network connections if needed. Okay, let's come back here to our
And is there some option for automatic, let's say, to define some automatic actions whenever you detect some risk, let's say?
Yeah. So for but this is based on the policy engine. So I will talk about it later on. So when there will be some policy violation detected, you can implement some actions that will be taken when this happens. And also the suspicious network activity is one of the type of the policies that we have. So this is type of the events that we can react on. So coming back here, I just wanted to show you also the image configuration. So when we analyze the deployment, we see what images are deployed, and here we can see here that there are what is the content of the image, and we can see very quickly what are the libraries inside, what are which of them are vulnerable, what are the CVEs that were detected. So here you see, as this is very outdated image, over 550 days, as far as I remember, you can see there is a lot of CVEs with very high score and which can be fixable. So it means that there are some newer versions of the libraries that should be updated in order to mitigate those risks. So very easily you can analyze different aspects of the application and the deployments that are installed in your cluster. Then maybe let's move now to the policy engine here. Yeah? So we have a built-in policy engine that provides set of built-in policies that can be extended. So you can easily implement here your own policies. So I have implemented one kind of more maybe for fun. The policy that detects the Java runtime inside the image. So we can quickly analyze how this can be done. So first of all, of course, you need to provide the name, severity, stages that are that this policy is related to. Then, of course, some description, rational remediations. Here you can also specify some restrictions or exclusions for executing the policy. So here, for example, I have specified that this policy should not be applied to any deployments that are inside the OpenShift dash anything namespaces in my project. In my class in managed clusters. Then based on the metadata that is collected by the policy engine, you can build your policy criteria. So here you can see that depending on the lifecycle stage, you will have different set of metadata that you can use for creating your policy criteria. So my policy here is based on the image content. So I'm checking basically whether there are some components or some libraries inside the or binaries inside the image that are either the prefix of the name is OpenJDK or Java with different versions. But you can see here there is a lot of different metadata that you can leverage to create different types of criteria. Then we have a quick review of the existing violations of our policy. So we can here see very quickly what deployments are not are violating our policy. So you can see here there are four of them. And then very important part, you can configure whether the policy should be enforced or not. And again, depending on the stage, for each stage, so build, deploy, and runtime, if your policy is related to runtime, you can specify here whether the policy should be enforced or not. So if you will enable enforcement, depending on the stage, you can see here what will be the behavior. Yeah. So for example, this build related enforcement means that if you will include this execution that of this policy as part of your CI/CD, what I will show you in a minute, of your CI/CD process, then it will fail here. Yeah. So the enforcement related deployments means that the deployment of the pod that is not compliant with the policy will be blocked automatically by the dedicated admission controller that is also deployed as part of the solution. And also for runtime is similar enforcement possible here. So this is how you can really react and act on violation of any policies that you have implemented. And of course, we have, as you have seen here, over 70 different policies with different severity. So and the implementations are changing over the time because there are some new vulnerabilities, new attacks implemented that make sense to create a policy in order to detect and to mitigate specific attacks. So for now, you can see there are only two with critical severity and a lot of with high severity rules that are implemented. Okay, so now maybe let's see how these policies can be enforced during the CI/CD process. So as an example, I will show you, actually I have to switch here, how you can define a simple pipeline using the OpenShift pipeline, so based on the Tekton solution for implementing the CI/CD processes. So I have here two very simple pipelines just to show you how you can quickly and easily execute the or how you can easily include in your DevOps the security controls. So this pipeline, these steps in the pipeline, they will simply check the image, will scan the image for vulnerability. So here I just need to copy the name of the image because this is the parameter that is required to run this pipeline. So of course in real world these steps would be a part of the pipeline that would probably first build a new image or maybe we try to deploy it somewhere, but now this is just a simple example of the security control. So you can see here that the image check step has failed, and this caused the whole pipeline to fail. And here we can look in more details into all the vulnerabilities that were detected. also on the bottom we can see that there were some policies violated, which had the build phase enforcement set to true. So that's why this specific step has failed. So of course, to remediate that, we would need to probably update the libraries that were found as a vulnerable here. And this idea is called shifting the security left. So it means that during we want to detect some vulnerabilities as soon as possible. So even during the building, we want to detect vulnerabilities, not to wait until the vulnerabilities will be deployed into the production or other environments and detect them at the runtime. The other pipeline here, which is even more simple, is the pipeline that will analyze the content of the deployment config, so the deployment manifest, Kubernetes manifest. So here, as an input, I need to provide a YAML file. So just to keep it simple, this needs to be base64 encoded, but where are we here? But you will see in a second that this is a real deployment. So I need to select PVC here because I need the persistence between these two steps, and it should execute pretty fast. So we should see the result of the analysis of the deployment very quickly, hopefully, or maybe not. Yeah, come on, you can do it. Okay, so the YAML has been saved, and now the deployment check step will analyze, and here we go. So you can see here that this deployment has any issues detected, but if you would, for example, try to create here some additional permissions, or you would maybe forget to create the resource limits, this kind of misconfigurations would be detected and reported as part of this analysis. So this is also very useful in your CICD pipelines to really run the analysis of your deployments configuration before you actually try to deploy the manifest into your clusters to avoid detecting some vulnerabilities late. And maybe the last thing to show you here, the or maybe not the last, but almost last. So the configuration management. So the configuration management allows us to analyze different security-related configurations of our clusters. So for example, we can check here what are the maybe let's see here. We can see the users that has a cluster admin permissions here, and also we can choose the cluster admin role, and we can analyze what users, groups, or service accounts has a cluster admin role assigned. So they are like super users in our cluster. Yes, and this is especially important for service accounts, which sometimes can be created and you might forget about them. But here you can see a lot of service accounts are OpenShift specific, so they are part of the different OpenShift namespaces. So probably you don't need to care about them, but you can see here there are some that are really part of the applications. Like here we see some service account. Also, if we move to the next screen, we can see here that also in our Visa processor deployment service account has a evaluated privileges, has a cluster admin permission, which has been shown in the risk profiler as well. And the last thing to show you here is the compliance. So very quickly, So here you can see a set of different regulations that the ACS will verify whether your cluster are compliant with. So of course, not all of them will be related to your specific application. So we have here like PCI, which is of course related to the financial data processing. Here we have the OpenShift CIS, so the extended version of Kubernetes CIS that is tailored to the OpenShift environments. So we can, for example, see here that there is a lot of different rules that are verified, and we can see whether we are compliant or not. So we are compliant with most of them, but there are some here that we are not really in compliance with. And pretty much the same, we can analyze any other compliance. So we can go to the standard we are interested in. We can see how compliant our cluster is. We can also narrow our analysis to specific namespaces. So if we want to just verify whether, for example, our medical application is compliant with the medical HIPAA standard, or our payment namespace, which actually should be somewhere on the bottom or even on the second screen. So here is a payments, how it is compliant with the PCI regulation, and then we can have a look in more details what requirements we are not meeting, what really should be done, because we can open every requirement and we can read what should be done in our cluster. So in this example, we should implement some network policies in order to be compliant with the firewall requirement that is specified by the PCI. Yeah, so this is more or less all for the demo. So as you can see, this is the really a complete dashboard, complete platform that makes the analysis or all the life cycle of your application from the security point of view.
Well, this is quite an impressive tool, I guess. It covers wide range of the views, wide range of the problems that are actually that can happen on every stage of the application lifecycle, and not only as we could see. Okay, so if you don't have questions now, we encourage you to ask them later. You can also notice that this is going to be published on the YouTube as well. And thank you for watching, and stay tuned for other webinars.